Now, children, our next chapter for this session is chapter number 6, that is waves and sounds. So, in this chapter, basically, this chapter is divided into two parts. The initial part of this chapter is related to waves, that we are going to discuss about wave characteristics, their properties, and then second part, the second half of this chapter is about sounds. Okay, that we will discuss about the sounds, how it can be produced, how it travels, and the various properties and the characteristics of the sound waves. So before I begin this chapter, just there is one question I want to ask to all of you. And children, just please pay attention. You have to listen carefully. It's a theoretical part. You have to pay attention, focus on my words. If sometimes internet signal is weak, and then if you are unable to listen to me carefully, or if the voice lag, so please remind me so that I can repeat that the same sentence. Now, the first thing I want to start, have you ever seen a pond, children? Okay, Ro, your name is Ro? Von Ro. Hmm? Who won? Hmm. Who won said that she has seen a pond. Jenny, what about you?
Yeah.
You have seen. I think that everybody have aware about a pond. So a pond is a pond, and that nowadays swimming pool is a smart version of a pond. Okay, and how does a pond look like? Here you can see in this picture. And one more question about this pond, and this is, what about state of water here? State of water here, children. This state of water means, what does it mean? State of water. In a pond, what a state of water? Tanzim. State of water, actually here they are talking about whether the water is in motion or is it at rest position. So we know that in a pond, the water remains stationary by neglecting the effect of air, by neglecting the effect of wind, basically that the water in a pond is stationary as compared to river, in the river that the water flow. So here water is still. Just remember, children, I will use many times example of a pond where water is still at rest. Now another picture here. So in this picture you can see, please look at this picture carefully. Water is falling from a certain height on a pond, maybe somewhere. And what you observe, children, what you observe here, when the flowing water, this water is coming at a certain height. In the chapter number 4, we had discussed about the concept of different kinds of energy and the different kinds of power plants also. So here that somewhere the water is stored at a certain height that contain a which kind of energy? Gravitational potential energy. And that gravitational potential energy is now, when the water is coming down certain height from a certain height, is converting into the kinetic energy. So water is falling, and the water molecules, that the water collide with the water molecule of a pond, that the reservoir here I can see. So one thing that my question is, what do you observe when you drop a pebble at a point in the pond? What do you observe, children? If you drop a stone, a small stone in a swimming pool, okay, or in a pond, what happens there? Please observe in this picture. Ripples formed, actually. Waves formed. Waves formed, actually. That is my question, children. Here in this animation on this picture, you can see that the waves are moving. Ripples are formed, Ripples. Ripples are formed. Now, if this happening, So now the next question is, children, is that disturbance confined to a place? What does it mean by this statement, children? Is that disturbance? Something is moving. When a stone collide the water molecules, then we have seen waves generated, disturbance generated, ripples formed. Is that ripples, waves confined to one particular place, or they start something moving? Tell me, children. What happens with the ripples? That the disturbance, actually, that the name ripples disturbance in the water molecules, you can see here. The disturbance not confined to a particular space, but it starts traveling, it spreads. Waves generated, ripples formed, and they start spreading out in the form of a circles. That if you ever observe this very closely, then the waves generated in a pond, that the ripples formed in the form of a circles, in the form of spherical circles, and from point where the water surface get disturbed, and they traveled, disturbance traveled, children. Now one more thing, next part, again I want to say, children, please listen carefully. What have you observed when you put a piece of paper or a small piece of wood on the disturbed water surface? When you put a cork or a piece of paper on the disturbed water, again, you are at the same place where near a pond. You have already created ripples. Now the question is, what happens or what do you observe when you put a small, maybe a ball, a plastic ball? What happens, children? Just I want to hear from some students. As per the question here on the screen, tell me, will the ball, will the cork, will the piece of paper travel in the direction of the wave? What happens, children, here? Just guess. If you don't know, let me explain it to you, children. And so the piece of cork starts oscillating up and down about the mean position and doesn't move forward. This happens, children. If you're thinking, no, 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 sir, it's not possible. This happens, my dear children. And you can also check, verify, and can do small experiment at your home also. The piece of ball, that the ball or wood, a log or cork starts oscillating up and down on the ripples formed. They move up, they come mean position and then come down. They start oscillating and doesn't move forward. Remember, we are talking about a pond. Water is still, disturbance has been created, wind effect we have neglected. So now, if ball is not moving, piece of paper is not moving forward, cork is not moving forward, so what is going forward? Waves are going, children. Disturbance are going. Ripples are moving. And basically the other word, energy, energy, energy is being transferred from the point where the stone has been dropped to another point. So basically, in a wave motion, when we are talking about a wave basically that carries energy from one point to another point, children. So here the disturbance is moving, waves are moving, energy is moved or moving from one point to another point. Please remember about it. Now, what do you understand from this example? And a disturbance is created at a point and it moves forward, but not the particles of the medium. Matter remains there. Now you see, if water is moving, so it means that the entire water shift from one position to the another position. But that not happen. The water remains in the pond itself. Water is not moving anywhere. Only the disturbance and the energy is moving from one position to another position. The water remains there. The water is not crossing the pond. It remains in its territory. Only the energy is moving. Disturbance are moving. Matter is not moving. Now, children, one more thing. What is a wave motion now? If someone asks you what do you mean by a wave motion? Wave motion is what? It is the disturbance that travels through the medium. In this case, water is a medium. Sound is traveling in air, air is a medium. So the disturbance that travels through the medium are to repeated vibration of the particle of the medium above their mean positions. Wave is actually what? It is the disturbance and which repeats periodically. They vibrate, they oscillate about their main positions, backward and forward, up and down about their main positions. It's a repeated vibration, children. It's a periodic motions, a periodic. And the motion is being transferred from one particle to another without the transport of the particles of the medium. That is a very, very important point, children. This point. Without the transport of the particles of the medium. Matter, particle of the medium, the matter is not moving. Only disturbance, energy is being forward. One particle transfers its energy to the neighboring particle, and in this way, energy is being transferred from one particle to another particle, and the wave moves and carry energy, even as well as momentum also. So another point, children, keep listening. This already we have discussed. What is the quantity that is transferred during the propagation of wave? What is moving, children? Energy is propagating. Okay, propagation of the wave, what they are carrying? They are carrying energy. Even though in this room, I'm sitting, children, I'm talking, I'm speaking, and energy produced by me, the air particles, they starts vibrating. And my energy, it travels from one position from my mouth to from my lip to the in this entire room, forward, backward, left, right, everywhere my sound is going. Basically, that the energy is propagating in all directions. Now, next point, children. Now, the question is again, do sound and light form waves? Means, does sound and light form waves, children? Sound travel in the form of a wave. Yes, in this chapter, that the sound part we will discuss later on. And light. I am the light of the world. Okay, so light, that the electromagnetic radiations coming from the sun, light travel in the form of a waves also. Light basically light has a dual natures. Light behave as a particle as well as a wave nature, but light travel in the form of a wave. Electromagnetic waves, radio waves, gamma rays, X rays travel in the form of a wave. We will come to this point also, children. But remember, sound and light, they form waves. But there is a difference between wave motion of a sound and in a light. Yeah, the answer is yes here. Now, does sound require a medium for propagation? Will you be able to suppose if we shift this classroom from Earth to a moon, and suppose we are taking our classes on moon, a physical classes, will you be able to hear me there? No atmosphere is there, particles are not there, air is not there, and due to that, you can't hear me. We can't even propagate means we can't do communication, and that's why the astronomers who ever visited on a moon, they use a different kinds of devices to communicate with each other. You can search on internet what kind of device they use for their communication. So sound required a medium, my dear children. If I create a vacuum in this room, even though if the vacuum is there, I can't survive here, I can't sit here. But suppose if a vacuum is there for a short period of time, if I am speaking, the other person can't hear me. For the sound, children, require a medium. Next point. Yes, without a medium, sound cannot propagate. Propagate means that the motions they're talking about moving from one position to another position. Similarly, does light require a medium for propagation? Very simple question. Does light require? No. Light doesn't require any medium. Light can pass through vacuum. Light can pass through medium as well as. Light can pass through air. In this room that I can see the light, visible light. And this light is coming from the heaven, means from the sun, from the very far distance. And where vacuum is there, no gases are there. So light, electromagnetic waves, they can travel through vacuum, and it can also pass through the medium also. Light can pass through the water also, liquid, it can pass through any medium as well as from vacuum. Now, light can propagate even in vacuum. Does all the waves require a medium for their propagation? This is the next question, children. Giveonly, does all the wave require a medium for their propagation? Just say yes or no.
Uh, no.
Yeah, correct answer. All the waves, no. All the waves, does all the waves require a medium? No, some wave require a medium, and even we have seen light doesn't require a medium for its propagation. Even you can also find other examples. Let's move to the next point, children. Okay, now we have some questions for practice. And question number one, whatever we have discussed, children, now I want to ask these few questions one by one. To first question is for Natania. Please read this statement, Natania.
Which of the following ways require medium for propagation?
Okay, now I'm giving you options. First option, electromagnetic wave. Second is UV, ultraviolet waves. Third one is the light waves. And the fourth one is the sound wave. Which of the following require medium for their propagation? Out of these four, Natania. Focus on saying, sorry,
A.
require medium. The question is require medium. Electromagnetic waves not require medium. So Yonwu, Yonwu.
Yes, sir.
That the question number one on the screen.
The answer is D, sound waves.
Sound waves, yeah, correct. Good. Sound wave is a wave that requires medium for their propagations. Next point, children. Means next question. And the next question is for Kevin. Kevin Ryan.
Yes, sir.
Now, if you could read this statement, please read the statement, Kevin.
Oh, is it transverse waves?
No, no, that I just want to say first read the statement louder.
What is transferred due to disturbance of medium?
What is transferred? Now, Kevin, they are asking about what is transferred. Now, let me show you the options, then you can find out the answer. Energy transferred, mass transferred, particles transferred, or velocity transferred. What we have discussed till now. What I told you, what is transferred? Tanzim, you tell me, what is transferred?
Energy.
Yes, very good. Energy is transferred, children. The disturbance means that the energy is propagating or transferred from one position to another position. And the last question, I think, which wave propagates in both medium and vacuum? sound, mechanical waves, light waves, none of these. Light waves. Yeah, children, this is the light waves. Light waves can move from medium as well as from the vacuum also. Now, children, let us move to the next point here. This is another important part, and this one is types of waves. We are talking about this entire chapter is based on the waves. But how many types of waves are there? So now you can see, children, here on the screen, we have many different types of waves. Let me show you, and even you want to take a snapshot, later on I will share these slides to all of you at the end of this chapter. Here, waves are basically classified into two categories. One is the electromagnetic waves, and the second one is the mechanical waves. Then we have mechanical waves divided progressive waves, and then the stationary waves. Waves can be stationary, that and longitudinal wave and the transverse wave. And in our grade 9 and 10, basically, we are going to discuss all of these, but more emphasis will be on the electromagnetic waves and then longitudinal and the transverse wave, that this part. And electromagnetic waves, some information I will give you, a brief information of all this kind of wave. But main thing is, children, just wait a minute, children. Now, children, we were talking about the waves. I think I need to receive this call. Just wait. So I was talking about waves. So we have a waves, as I told you, the different kind here. And let me move to the next screen, children. Next slide. Now, first, let us discuss something about this electromagnetic waves. Even though that electromagnetic waves detailed study we will do in our next chapter, but some information about the electromagnetic waves, that its definition, the sound wave. Actually, sorry, not the wave, or waves which travels in the form of oscillating electrical and magnetic fields are called electromagnetic waves. This is the standard definition of EM waves, the waves coming from the sun. The waves which travel in the form of a oscillating electrical field is there and magnetic fields are there, and that is called the electromagnetic waves. Such wave, such wave means that the electromagnetic waves doesn't require any medium for their propagation. So they are also known as non-mechanical waves. So if electromagnetic waves are also called a non-mechanical wave, then we can say that the waves are divided into the two categories. One is the non-mechanical waves and the other one is the mechanical waves. If non-mechanical waves doesn't require any medium, so it means that the other side, the second kind of wave, mechanical waves, they require what? A medium for their propagations or for their movement. All electromagnetic waves travel through vacuum with the same speed as the speed of light. Electromagnetic wave, it's not a one wave, it's a spectrum. Many waves. Examples you can see: radio waves, microwaves, X-rays, visible, UV, gamma rays. All these waves travel with the speed of light. And what is the value of speed of light, children? You please make a note of it and try to memorize this value. 3 multiplied by 10 to the power 8 meter per second. Means radio wave is moving with a speed of 3 times 10 to the power 8. Sound microwave is moving 3 times 10 to the power 8, and similarly for the visible light and UV light. So the electromagnetic waves contains a spectrum where we have radio waves, microwaves, visible and UV light, and also other waves. Visible light, this visible light, in this spectrum there is a small portion of wavelength and frequency, and that visible light which help us to see the objects. We can see the objects, you can see me, I can see you, I can see all the objects on the earth due to the visible light. Similarly, mechanical waves, children, mechanical waves which require material medium for their propagations are called mechanical waves. That's the second category of the waves, mechanical require medium for their propagation. These waves are also known as elastic waves because they depend on the elastic properties of a medium. They depends on the medium, particles of a medium. How many particles means the density of the particle, density of a medium. So mechanical waves completely depends on medium and the elastic properties of a medium. Elastic properties means that the particles of the medium, they oscillate back and forth, means back and forth and up and down. So they return back to their position. Only energy transferred. Examples of mechanical waves. You can see the example, children. Sound waves. We are talking about sound waves. That the second half of this chapter is about the sound waves. Sound wave is an example of a mechanical waves, which requires a medium. Water waves. Water waves generated in a pond, in a river, or anywhere. So the waves generated, ripples generated in a medium. Seismic wave. Wave produced during the earthquake. And here in Indonesia, that is a very sensitive, country for the earthquakes, and regularly earthquakes come here. And so the waves generated during the earthquake, that is called the seismic waves, that also requires a medium for their propagation that travel through the grounds. Just a few minutes left. Now, children, one last thing that I want to discuss: a spring model for propagation of wave through an elastic medium. I think instead of this, just remember this diagram. I will come back to this diagram, and but few seconds left. Even you can read some point here, a propagation of sound waves, children. A small region of air is considered as a spring, so it is connected to the neighboring regions or springs. When sound wave propagate through air, it compresses or expands in a small region of air. I think now, children, what is there? Sound waves, children, I'm speaking here. The sound waves